10-4, we're doing the algebra of matrices. So we're going to do operations with matrices. We're going to add, subtract, multiply, and then we're also going to learn how to solve matrix equations. If two matrices are equal, they have to have the same entries in the same positions. So they're only equal if they look the exact same. Okay, and then if you are given two matrices, in example 1, it says to find A, B, C, and D. If you're given the matrix A, B, C, D is equal to 1, 3, 5, 2. So like I said, that's pretty intuitive. So it's just the positions are equal. So A is in the top left corner, so that's going to be equal to 1. B is in the same position as 3, so those are equal. C and 5 are in the same position, so those are equal. And then D is in the same position as 2, so those two are equal. All right, and then the next thing we're going to talk about is addition, subtraction, and scalar multiplication. So two matrices, they can be added or subtracted if they have the same dimension. If they don't, then we would say that that was undefined. Okay, their sum or difference would be undefined if they don't have the same dimension. Okay, and anytime we add or subtract, we're just going to be adding or subtracting those corresponding entries. So if it's in the same position, you're going to add or subtract. Okay, and then if you are multiplying a matrix, you are just going to distribute that scalar multiple. Okay, so the scalar multiple just means you are multiplying by a number. Okay, so you're going to distribute that to all of the entries. Okay, and then this information box just tells you a little bit more about that, how if you are finding the sum, you are adding those corresponding entries together. Difference, you're subtracting them. Scalar product, you multiply the scalar by each entry. Okay, so I want you to do the operations for example 2. Okay, so A is a 3 by 2, B is a 3 by 2, C and D are both 2 by 3s. Okay, so if you can perform the operation, you're going to add them together, and if you can't, you're just going to divide. They're not divide. It's undefined. Okay, so you can only add them if they're the same dimension. So if they're not the same dimension, you're going to write undefined. So you guys are doing example 2 right now, so you should be adding them together. So you're just adding your corresponding entries. Okay, so if you are adding A plus B, you just have to look and see what the corresponding entries are. So 2 plus 1 is going to be 3. Negative 3 plus 0, negative 3. All right, and then Ilaria, what did you get for row 2?
Negative 3.
Yeah. Okay, and then Jaden G, what'd you get for row 3? Good. Okay, and you can write 3/2 or 1.5, whichever one you want. Okay, and then B is going to be subtraction. So these are 2 by 3s. So if they're 2 by 3s, your result is going to be a 2 by 3. Okay, so 7 minus 6 is 1. Negative 3 minus 0. 0 minus negative 6 is going to be what? Positive 6. Great. Okay, and then Farrah, what'd you get for the bottom row? Great. All right, now when you go here, the C plus A, C is a 2 by 3, A is a 3 by 2. So if they're different dimensions, it can't be performed. It says to carry it out or explain why it can't be performed. So this is undefined. Okay, and the reason why is because they're different dimensions. Okay, so we know C is a 2 by 3, A is a 3 by 2. Okay, so we cannot add them together if they're not the exact same. Okay, and then the last one, we're going to be multiplying. So you really just distribute. This is a scalar multiple. So we multiply everything by 5, okay, times A. So we should get 10, negative 15, 0, 25, 35, and then when you do 5 times negative 1/2, how are you guys writing that? Okay, negative 5 halves, negative 5 over 2, negative 2.5 is fine as well. All right, so like I said, that's pretty intuitive. Okay, that's what you would predict we would do. So we're also going to talk about the properties of the addition and the scalar multiplication, because we are going to have some properties that don't hold up. The ones that do hold up are the commutative property of matrix addition, which means it doesn't matter if you add A plus B or B plus A, you're going to get the same answer either way you do it. And with the associative property, if you have 3, it wouldn't matter if you add A and B first and then C, or B and C first and then you add that to A. Okay, and then with the scalar multiple, you could add, you could multiply D times A first and then multiply by C, or you could multiply C times D first and then multiply by A. Okay, so the scalar multiplication, that's going to hold true, and then the distributive properties, that's going to hold true as well. So you can distribute A to C and D, okay, or you could distribute C to A and B here. All right, so we're going to solve matrix equations. So in step 1, we're going to be solving the equation for x. So your matrix equation is 3x minus 4a equals b. They give you A is this matrix, and then I forgot to type in that this one was B, and B is equal to negative 13, 1, negative 3, negative 2. Okay, so the first thing we're going to do is just solve the equation for x. So we have 3x minus 4a equals b. So if we're getting x by itself, we would add 4a over first. And it doesn't matter if you put b plus 4a or 4a plus b. I'm going to do 4a plus b. Okay, and then we really, we don't technically divide when we have matrices. We multiply by the reciprocal. So we're going to multiply both sides by a third, okay, to undo the 3 from the x. And then you can write this as 1/3 times 4a plus b. Okay, this is the distributive property with the scalar. You can leave it like this, or if you want to distribute, you could do 4/3 a plus 1/3 b. And then we're going to plug in the matrices and evaluate. So I think it's easier to do this equation. I think it's easier to multiply by 4, then do the adding, and then multiply, rather than getting all these fractions involved here. So we're going to do x equals 1/3, and then it's 4 times the matrix A. So we have 4, -1, 3, 2, and then it's plus matrix B. Okay, so once you distribute, you have 16, -4, 12, and 8. And then we're going to add that. Okay, so we distributed the 4. Now we're going to add the corresponding entries together. So 16 plus -13 would be 3. -4 plus 1 would be -3. 12 minus 3 is 9. 8 minus 2 is 6. And when we're multiplying by 1/3, we're just dividing everything by 3. So we have 1, 3, -1, 2. Okay, and that is our solution for x. Now again, you could do it this way as well. You could do the scalar multiple times a, this scalar multiple times b, and then you can add them together, okay, and you would get the same outcome. All right, we're going to move along to matrix multiplication, which is more complicated to describe. So first we're going to talk about when you can multiply two matrices together. So the product is defined only when the number of columns in A is equal to the number of rows in B. So if we write those dimensions side by side, what you'll see are these inner numbers have to match. So these have to be the same. And if those are the same, then your result is going to be this M by K matrix. So if the dimensions of A and B match, then the product has the dimension of M by K. So you'll always be checking to see, oh, are these two the same? If they're not, you can't multiply it. If you can, then M by K becomes the dimension of the result matrix. Okay, so MK is the result matrix. Let's do an example with numbers because I feel like that helps. So if you were to multiply a matrix that was a 2 by 3 and a 3 by 4, you would check and say, okay, 3 and 3 are the same. So then the result is going to go in a 2 by 4 matrix. Okay, now the reason it has to happen like that is because there's this special procedure, and we find something that's called the inner product. So we're going to define the inner product for a row of A and a column of B. Okay, and that is on the next page. Okay, so the inner product you can find if you take this first row of A and you take this column of B, and then the inner product is going to be the sum of those products. Okay, so their inner product is the number found by adding those products together. Okay, so you take A1, you multiply it by B1. Okay, and then you do A2 times B2. A to the n times B to the n. And then you add all of those together. So we're going to practice that with this. So this is your A1, A2, A3, A4. Okay, this is your B1, B2, B3, B4. So what this is telling you is you do A1 times B1. So we do 2 times 5, okay, plus -1 times 4, plus 0 times -3, plus 4 times 1/2. Okay, so we find the sum of those products. Okay, so we have 10 minus 4. This would be 0 plus 2. Okay, 6 plus 2 is going to be 8. So this would be our entry into the result matrix. Okay, and the entry is determined by the row and the column. This would be your only answer because it's a 1 by 4 and a 4 by 1. Or, 1 by 4 and a 4 by 1, which means your result is a 1 by 1. So your answer for that would just be this, would just be 8. Okay, so the product of AB is found with matrix multiplication. Okay, so if you have an m by n matrix and an n by k matrix, their product is the m by k matrix, which is formed by that inner product, which they just say it's the ith row and the jth column, and we write this is the product, which I don't think is very helpful. So we're going to go through the process together, okay? So the definition says that each entry in the matrix is obtained from a row of A and a column of B. And then that entry is the ith row in the jth column. So let's actually do one of those together. So this is your second row. This is your second column. So if you're doing the second row, the second column, the place it goes is in C22. So it's the inner product of row 2, column 2. Okay, and then sometimes you do the first row, second column. That would be C12. If you do the third row, the first column, C31. All right, so now we're going to practice this together. So we're going to calculate the products AB and BA if possible. So the first thing we have to do is make sure it's possible. So if we try A times B, Okay, we're going to look at the dimensions. So we know from earlier in this unit, this is a 3 by 2. And then what are the dimensions of B? 2 by 2. Okay, so check the two innermost values. If they are the same, then yes, we can multiply. Okay, and then this is going to give you your result. So your result is a 3 by 2. Okay, we're going to write these out so that we can mark them up a little bit. So we have 4, 1, negative 3, 0, 2, negative 1. Okay, so we're going to start here. We're going to find C11, which means we're going to do the first row and the first column. Okay, so the first row is 4. And then it's 4 by 1. I'm going to show you how we're going to multiply 4 by negative 1. And we're going to multiply 1 by 3. Okay, so we do the first times the first, the second times the second. So 4 times negative 1 plus 1 times 3. Negative 4 plus 3 is going to be negative 1. Okay, so in the result matrix, which is a 3 by 2, we're going to put negative 1 into C11. Okay, the next thing we're going to find is C12. So again, we're taking the first row, so 4 times, but now we're doing the second row. So we do 4 times 2 plus 1 times 1. So 8 plus 1 is going to give us 9. Okay, now we're going to move on to the second row. So when you do the second row, you're going to have the second row, the first column, and then the second row, the second column. Okay, so you're going to multiply negative 3 by negative 1. So negative 3, negative 1, and then 0, 3. Okay, so we're going to get 3 there. And then negative 3 times 2 plus 0 times 1. And we know anytime we're multiplying by 0, that's going to cancel out. Okay, when you're doing this, there needs to be some type of work shown. So if you want to write out the plugins and then do mental math, that's fine. If you'd rather write out negative 6 plus 0, that's fine too. Okay, and then in our last row, we're going to do C31, C32. Okay, I think it's helpful, like you can see here, see how you did 4, 1, 4, 1, because that was the row, negative 3, 0, negative 3, 0. Sometimes I think it's easier to just do 2 times something, negative 1 times something, 2 times something, negative 1 times something, and then do the plugins. Because for the first row, you're going to have negative 1, 3. For the second row, you're going to have 2, 1, and then you can just do your mental math from there. So negative 2 minus 3 is negative 5. 4 minus 1 is 3. Okay, and then this is your final answer. That's the product of AB. Okay, so it says find AB and BA if possible. So if we're doing B times A, B is a 2 by 2, A is a 3 by 2. So your first step is checking to see if these two are the same. If they're not the same, then you can't perform the operation. So in this case, we can just say that it's undefined. Okay, so it's undefined when the rows do not match the columns of the second. Let me set that backwards. Your columns don't match your rows. All right, and then from that, we know that matrix multiplication is not commutative. So it does obey the associative and the distributive, okay? But we know it's not commutative because we just tried to do B times A, and those were not equal. Okay, so it is not commutative, okay, but these other properties do apply. So the order in which you do these in does matter. Okay, so associative, you multiply B and C first and then by A. The order that these are written in is going to matter. Okay, you can add B and C and then do A times B plus C, or you can do AB plus AC. Okay, and then the distributive property is going to apply as well. Okay, and then even if you can find both AB and BA, they aren't necessarily equal. And this proves that matrix multiplication is not commutative. Because even if you can find them, they're not going to be the same. So we're given A and B. We're going to calculate those products. All right, so I want you to see if you can do A times B by setting up your dimensions. Okay, so they're both 2 by 2. So if it's a 2 by 2 and a 2 by 2, your result is a 2 by 2. So yes, we can do this. Those are matching, so 2 by 2. Okay, and then if you guys just want to use these and mark those up, that's fine. So your AB is going to be a 2 by 2 result. Okay, so what we have to find is the C11, the C12, the C21, and the C22. All right, so we're going to start first row, first column. So the first row is 1 and 2. So the 1 gets multiplied by 6, the 2 gets multiplied by 2. 6 plus 4 is going to be 10. Okay, do you guys think you can do the rest of it? Let's give it a try. All right, let's see how we did. So for C12, we should have 1 times 0 plus 2 times 3. Okay, so your result is 6. All right, and then for your last row, again, I do think it's helpful, once you know what your row is, it's -1 being multiplied and then 4. So -1 and then your 4. So if you want to write that out first and then go back and do the first column and then the second column, you're welcome to do that. -6 plus 8, what'd you guys get? 2, and then 0 plus 12, you get 12. So then this goes in the second row, first column. Second row, second column. Okay, so this is going to be your solution. And then if you haven't started the BA already, let's do that. So they're both 2 by 2s. So if it's a 2 by 2 and a 2 by 2, again, you're going to have that 2 by 2 result. So these are the same. So this is your result. Okay, and then because you are like flipping the order of this, you should write them out. So 6023, okay, times 1, 2, -1, 4. Okay, so we're going to do C11, C12, C21, C22. Okay, so first row, first column. 6 times 1 plus 0 times that. And once you know it's 0, if you just want to write the 0, that's fine. I'm going to write this out so you can look back and see how we got there. Okay, and then for the second row, again, you have the 6 and you have the 0. Okay, so 6 times 2, 0 times 4, is going to give you 12. 6 and then 12. Okay, and then here you have the 2, 3, and then the 1, 1. So 2 and 3, 1, -1, 2 and 3, 2 and 4. Okay, so 2 minus 3, -1, 4 plus 12, 16. All right, how are we feeling about this multiplication here? Getting the hang of it? Not hard, it's just different. All right, and then the last thing we're going to do is talk about how to handle when you're trying to find the product when you have 3 matrices. So you're given A, B, and C, or A, H, and C, and we're going to find the product. So you have 2 options. You could do A times H first and then multiply by C, or you could do you could do H times C first and then multiply that by A, but A has to go in front, okay? Please note that this is not the same thing as doing HC times A in this order, okay? Because if you try to do it in this order, then you get something that's undefined. So when you write them out, this has to go in front. Okay, so let's make sure that we can do this. So if we do A times H, A is a 2 by 2, H is a 2 by 2. Okay, so A times H would give you a 2 by 2 result. Okay, that's what we would do first. Then if we multiply by C, C is a 2, 3. So 2 and 2 match. Your final is going to be a 2 by 3. Okay, when you do those. Okay, and again, you can choose if you want to do AH first or if you want to do HC. Okay, so we're going to do 2, negative 5, 0, 7, 3, 1, 2, negative 1. Okay, so you have C1, 1, C1, 2, C2, 1, C2, 2. Okay, so go ahead and do the first row, first column if you haven't already. Okay, so do this on your own and then you can check with mine. Okay, so you should have negative 4, 7 for your first row, 14, negative 7 for the bottom. So this is AH, and then you have to multiply that by C. Okay, so your C is 2, negative 5 halves, 0, 0, 2, negative 3. Okay, so remember, your result is going to be a 2 by 3. Okay, we'll write our final result below here. Okay, so in this case, we have the first row, the first column, first row, the second column, and then we have the third column. So anytime you're doing that first row, like I said, you can do the 4 and the 7, negative 4, 7, negative 4, 7. For me, it's quicker for me to write it like this and then do the mental math. You can choose what strategy works the best for you. And then my first row is a 2, 0, negative 5 over 2, 2, and then 0, negative 3. So then I have negative 8 here. This, you can multiply the top and divide by the bottom. Negative 4 times negative 5, 20. 20 divided by 2 is 10. 10 plus 14, 24. And again, if you would rather like do this part in your head and then just write out the 10 plus 14, that is fine too. There just has to be some level of work there. Okay, so whether you're writing out the multiplication or the product, that's up to you. So now I know it's negative 8, 24, negative 21 on top. And then for my second row, I have the second row, the first column, second row, second column, second row, third column. So 14, 14, 14, I'm going to be multiplying that. Okay, and then I'm going to plug in my rows. So I have 2, 0, negative 5 over 2, 2, 0, negative 3. Okay, so I have 28. For this one, I would divide first. So 7 times negative 5 is negative 35. Negative 35 minus 14 negative 49. And then a negative times a negative is going to be a positive. So I have 28, negative 49, positive 21. And that is my final answer. All right, so for this section, in 10.4, numbers 17 through 19 are odds. And then 25 through 33, you're doing the odds only in part A. Okay, so there's multiple parts. So for these, you just have to do your part A.